Air conditioner is one of the most desired household appliances in the world. But have you ever wondered how your air conditioner manages to keep you cool and comfortable, even when the temperatures outside are soaring? Well, wonder no more. Today, we're going to dive deep into the inner workings of your trusty air conditioner and uncover the fascinating science behind its cooling magic. So, let's roll up our sleeves and get started. The fundamental working principle of an air conditioner is simple. A cold refrigerant is continuously passed through the conditioner and a fan blows air through it. The cold refrigerant cools the air, and the air is blown into your room. First, let's understand some important basic thermodynamics concepts before learning the working process. You might have heard that we can boil water just by decreasing the pressure. Yes, that's true. Temperature is directly proportional to pressure. That means, as we decrease the pressure, the boiling point of water also decreases and vice versa. Now let's discuss the air conditioner. To understand how an air conditioner works, let's start by breaking down its key components. At the heart of the system is the compressor. Think of it as the engine that drives the entire cooling process. The compressor pressurizes the refrigerant, transforming it from a low-pressure gas to a high-pressure one, while also increasing its temperature. Here a spiral type of compressor is used. As the gas enters the spiral, space becomes crowded and the gas is compressed. After being compressed, the gas is discharged from the pipe above. This type of compressor is very energy efficient and makes less noise. Next in line is the condenser. This component is kept outside of your home. As the hot, high-pressure refrigerant gas flows through the condenser coils, it releases heat into the surrounding air and condenses into a high-pressure liquid. This crucial step is what allows your air conditioner to expel the unwanted heat from inside your home to the outdoors. The refrigerant is now cool but at high pressure, so to lower the pressure we introduce another important component called the expansion valve. This component might be small but plays a crucial role in the cooling process. As the high-pressure liquid refrigerant passes through the expansion valve, its pressure drops suddenly, causing it to expand and cool down significantly. For example, when we spray perfume and then the surface of the perfume is a little colder than usual when we touch it, these phenomena happen because of a sudden pressure drop. When the refrigerant experiences a sudden pressure drop, some portion of the refrigerant evaporates into vapor, and the energy required for evaporation is achieved from the liquid refrigerant. As a result, the average temperature of the refrigerant also decreases as the heat is lost. This process is also called latent heat of evaporation. Then the cold liquid is passed through the evaporator coil. This is where the real cooling action takes place. As the cold, low-pressure refrigerant enters the evaporator coils, it absorbs heat from the indoor air, causing the refrigerant to evaporate into a gas once again. The now cooled air is then blown back into your living space, creating that refreshing breeze you love on a hot summer's day. And the cycle continues, with the refrigerant being pumped through the system over and over again to maintain your desired temperature. But now here comes one issue. The compressor used is a spiral-type compressor which can only compress vapor, and if the liquid is fed into the compressor, the whole system may stop functioning. That's why the evaporators are desired to convert all liquid into vapor and even raise the temperature by a few degrees after conversion. Now the question is, how does it ensure whether the fluid entering the compressor is pure vapor or not? This case is handled by a special type of expansion valve called a thermostatic expansion valve, or TXV. It is quite similar to the expansion valve we saw earlier, but this time this valve consists of a bulb that controls the needle. The bulb is separated from the main refrigeration cycle using a diaphragm. The bulb is placed in contact with the evaporation coil's exit. When the bulb is heated, the refrigerant inside the bulb will expand, then it will exert pressure on the diaphragm and the needle will move down. When the needle moves down, then the restriction is widened, and when the needle moves up, the restriction is narrowed. When the refrigerant inside the evaporation coil is not converted completely into vapor, then it will not be superheated. The bulb will immediately sense this low temperature and the liquid inside will contract. Then the pressure on the diaphragm will also decrease, causing the needle to move upward and narrowing the restriction. A narrow restriction causes a good amount of pressure drop, which will cause a temperature drop. Thus it can absorb a good amount of heat due to its low temperature. This will make sure that all the liquid is converted into vapor. Due to the low temperature of the evaporator coil and the continuous flow of cold liquid, water condensate is formed, which is collected and removed through a pipe. We hope this video helped you understand the working of the air conditioner and you've enjoyed learning about how your AC keeps you cool and comfortable. Thanks for watching the video.